All right, so the next thing is called a circuit. So a circuit is a path that begins and ends at the same vertex. And the figure below, the path given by, and we're going to start with B, is going to go from B to D, D to F, F to E, and E back to B. So that's a circuit. It's closed. It starts and ends at the same place. Now, notice every circuit is a path because, we're going all around the whole thing and we're not crossing any edge twice. And so that's true. But not every path ends and begins at the same vertex. So not every path is a circuit because if we started at, say, instead A and we ended at G, we could make a path. We could go A to B, B to D, D to F, and F to G, and that would be a path. But it's not a circuit because we didn't end up back here at A. Okay, so that's a kind of the key. Not every path is a circuit. All right, so a graph is connected if for any two of its vertices, there's at least one path connecting them. Thus, a graph is connected if it consists of one piece. So everything in the graph has to be connected. Now, if a graph is not connected, it is said to be disconnected. And a disconnected graph is made up of pieces that are by themselves connected, and each of those component pieces or whatever are called components of the graph. Okay, so if we look here, connected graphs here on the left. So, every vertex is connected and we can draw a line between everything and we can get back to where we started. Same thing here. All these are connected no matter how we go. We can get to every point and not have to lift our pencil. Now, what about disconnected graphs? Well, here we can go around that triangle 100 times, but we're never going to get over here to D. So these are disconnected. So there's this break here from B to D that we don't have. Same thing goes over here. We can go around this thing many times, but we'll never get over here to this triangle. And so here it's disconnected. We don't have that B to E, which we had over in this case. And here don't have the B to D, which would cause it to be connected. If we put those back in, that would be connection. Okay. Now, a bridge is an edge that, if removed from a connected graph, would leave behind a disconnected graph. And so this then is a bridge, and this then is a bridge. Now, and like I said, in this one here, BD is the bridge in this case, because when we remove it, it becomes disconnected. And here, BE is the edge that if we remove it, it's the bridge and it becomes disconnected. Okay, so that's kind of how it works. And we could make these different ways. We could remove different ones, and we could have removed like A, B here, and then it would be disconnected instead of BE. And so that's kind of how it works. So just not always it's going to be one possible thing to make have a bridge. It can have multiple bridges. All right, so use the graph here and to answer each of the following questions. Find the degree of the vertex A and the degree of vertex E and determine whether each of these vertices is even or odd. All right, so we want A and E. All right, so up here on the right, we have A. So we have 1, 2, 3, 4. So that has degree 4. And E, we have 1, 2, 3. So that's degree 3. So we have for 1, A equals degree 4, and that's even. And then E is degree 3, and that is odd. All right, what about 2? Which vertices are adjacent to vertex C? All right, so we want to look at C and see which ones are adjacent to it. Well, if we look here, what's adjacent to it? Well, B is adjacent to it, A is adjacent to it, and E is adjacent to it. So here we can say A is, B is, and E is. Okay. Now 3. Use vertices to describe two paths that begin at vertex A and end at vertex F. All right, so two different ones. Again, we can't cross the same thing twice. So maybe let's do two colors. We'll do red first. Oops. We'll go A to B, B to C. Now we're going to F. And then C to E, and then E to F. So that would be one. So we can go A, B, C, E, F. Now let's change colors. Let's go maybe this color. And what color do we have? That'll work. Let's do it a brighter color maybe. Let's do green. green. All right, so another way we could do it, we could go instead, we could say, well, let's start at maybe, oh, where's my mouse here? There we go. A to C, C to E, then we could go E to D, and then we could go D to F. So that would be a different one. So our second one we could write is we went A to C, and then to E, and then to D, and then to F. So those would be two different paths that begin at A and end at F. All right, so the next one, use vertices to describe a circuit that begins and ends at vertex D. All right, so 4, it begins and ends at vertex D. So let's start a different color again. Let's do purple. So we're going to start and end here. Well, a really easy circuit that we could do would be here, down to here, and back up to here. Where'd that one go? All right, so for 4, we could go from D to E to F and back to D. Or we could go D, F, E, D. We could go back the other direction. But in either case, that's all we can do. Because if we go any further up to the top up here, we're going to start crossing over and things like that. And we don't want to do that. Okay. Let's see. Now, which one? Which edges are not included in the path here? All right. So for 5, we're going from B to A. So now let's maybe erase some stuff here because we have a little much to follow. So let's erase that. All right. So now, all right. So we're going to go from, and here we have B to A to C, C to E, to F. Oh, okay. That A, we forgot we went around the loop there. That's what that A means there. That one here. Then E goes to F. F goes to D. And so now it says what edges are not included. Well, what's missing? Well, what's missing is, let's make that, we have this piece is missing and we have this piece is missing. So we have BC and DE are two pieces that are missing. All right, and then the last question, explain why CE is a bridge. Well, CE is this piece here. So a bridge, remember, if it says if we take that out, then we end up with a disconnected graph. Well, if we take that out, we've got two pieces. Those are the two components, and therefore it's going to make a disconnected graph. So if removed, basically, if removed, it becomes a disconnected graph. And so that's why CE then is a bridge. All right, so hopefully that helps you get through this section. And if you have any questions, please feel free to contact me.